I'll just talk about the basics that are very relevant to solving real-world problems, which is applied machine learning. So basically, what I have here, for example, is a machine learning program where we have, let's say, we feed it a lot of data, and this data we feed it, we call it a training set. And when we feed this data into a machine learning algorithm, the machine learning algorithm learns and extracts maybe certain features. And once we are very sure, we've tested, we are very sure that the machine has learned, then we give it information that it has never seen, okay? And then we give it to say, now predict what is the outcome of this. And if it gives us a good result, then we are sure our classifier, for example, is very okay. But if it predicts, for example, we give it a cat and it says, no, this is a dog, then this becomes problematic. So we have to train over, again, this machine learning, or we change some parameters and so on and so forth. It will be very easy, but for someone like me who doesn't have a computer background, or anyone out there in the audience, this is basically the difference between a traditional way of programming and machine learning approach. Basically, if you are making, let's say, a program or a software, a traditional way, first we start the problem, and then you sit down and you write the code, you put in all the rules you want, and then you evaluate if it's okay, you analyze the errors. If the program is okay, it's bug-free and so on, you can launch it. But this becomes problematic because not all problems can be approached this way, especially problems that are random, non-deterministic, or they are too complex to write all the rules. It will be too impossible to do that. So instead, what we do is after we start the problem, we collect now the available data. And this data, we feed it into a machine learning algorithm. And once the algorithm learns from this data, then we evaluate it by giving it the test data like I mentioned earlier. And if it's not okay, we have to iterate over, or if it's very okay, we can actually deploy this machine learning model, maybe for use in industry or something. Earlier I mentioned like machine learning, AI and deep learning. Mostly these are common terms that are used. The machine learning models that I gave previously, most like the classical machine learning models, maybe if it's a classifier, the first thing that you have to do, maybe if you are creating a classifier, is your input. First of all, you have to manually select the features as an AI engineer or a data scientist. You have to select the features manually, and then you put into your model, and then you get what you want. This was the first way, but it is very, very difficult to really implement this, especially if you don't have that domain-specific knowledge. And for example, images, it's so difficult to do that because sometimes you find that this image is skewed or upside down. So how do you extract the features, because the pixels and the distribution is not the same? Maybe the data is coming from the same class. So this becomes problematic. So another way to do this is perhaps to think of other architectures that do not require actual manual extraction or feature engineering. What the machine learning model does, you just give it input data as it is. If it's an image, you feed it as it is, and then starts to extract. Of course, now this architecture changes. It now draws in like inspiration from how our visual cortex processes the data, and this is was the birth of convolutional neural networks, which are very good at image recognition. Yes, so this is deep learning is also machine learning, but it is a newer kind, and you don't really have to sit down and extract features manually. So it does all that for you. But all you have to do is that you need some good pre-processing when you are making your model, because as the saying goes, garbage in, garbage out. If your data is very, very, very unstructured or not in a way, packaged in a way that the model is supposed to receive that data, even the results that you are going to get, they are going to actually be affected by how clean your data is. So that being said, some of the ideal tasks that can be used for our machine learning, these are problems for which existing solutions require a long list of rules. Like I said, you don't have to write all the complex rules. And the other task could be maybe to solve complex problems for which there's no good solution using a traditional approach. And also non-deterministic problems. What we mean by non-deterministic problems is that it's very unpredictable what might happen next. So to really come up with, let's say, a mathematical description of that, it becomes very difficult. So, and then also the last one is getting insights about complex problems and large amounts of data. So these become ideal tasks for applied machine learning. So when you are making, maybe you have a project, it's not everything that you can do with machine learning, okay? So you need to analyze, does this really need a machine learning? And I know it's very tempting whenever you think of a problem, the first thing you want to do is, how can I apply machine learning? So, no, some problems actually can be solved just using traditional ways. So when you are making, when you are working on your problems, please be mindful of this. Sometimes the solution lies actually in the simplest, not in the complex. Like I said, machine learning has gone mainstream already, and we are actually using it every day. I'll give an example, like in web search. We use Google every time. They are using machine learning, and natural language processing is actually thriving. Then also in our e-commerce recommender systems. And one of the tools that I'm using here, because I don't speak Japanese so well, is actually Google Translate. It's helping me actually to use machine learning. I'm already using it quite handful. And then also earlier in the chat, in the morning talks we heard that the first introduction where chatbots were talked about. They are being used actually in banks and by so many companies actually to automate maybe virtual communication. Even in healthcare, we have now virtual nurses or virtual doctors. They're using chatbots and so on and so forth. And then the other upcoming one is self-driving cars. It's though the technology is already here, and this is why deep learning is very much being used, and other products like Siri and also Amazon's Alexa, all these are powered by AI or machine learning models. So that being said, what are some of the types of machine learning methods that you are going to encounter as you start your journey? I've listed this based on the training basis. And the first types of machine learning algorithms is what we call supervised learning. So with supervised learning, I've given an example there. We have a lot. So we feed the algorithm a lot of data, labeled data, and then after it has learned enough, then we test it. So some of the tasks that you involve, like we call supervised learning, is classification, regression, and prediction. We have, most of us can say we all have emails. We know that automatically spam messages are actually filtered direct into the spam folder, and also regression, which is very much used in pricing, and also sometimes it can be used for other things. Yes. And then we also have unsupervised. So for unsupervised learning, it's another way of training machine learning models, but actually what we do is give it data which is unlabeled, and it's up to the algorithm now to find meaning in that data. And the tasks that can be ideal for supervised models is clustering, dimension reduction of data, anomaly detection such as fraud, and also we have reinforcement learning, though reinforcement learning compared to supervised and unsupervised, there's the application is not so much, besides the current like stride, like Go, like recent few years ago, how the Go champion actually was beaten by the AlphaGo developed by DeepMind. But reinforcement learning also have in self-driving cars, in robotics. Then as you practice your machine learning, you find that sometimes it's actually not necessary to build from scratch. Sometimes you can actually take the already pre-trained models and use them actually for your task, transfer learning. So there are already models you can use for transfer learning. I'll show you the models that you may use for specific tasks later. So for supervised learning, these are some of the most common algorithms that you come across. Supervised learning, like k nearest neighbors, linear regression, logistic regression, SVM, support vector machines, decision trees, random forests, and naive Bayes, and neural networks. So you can use this for supervised learning for problems such as classification, regression, and prediction. So if you are developing a model, like I said, have to sit down. What is the problem? Is it classification, or is it regression, or is it a mixture of both? In that way, then what can I use? What approach can I? What is my baseline model? And I would encourage, when you start creating your machine learning, always begin with the simplest baseline, and then you compare with the other more perhaps advanced models. For unsupervised learning, the tasks such as clustering tasks, when you are working on maybe text documents, or if you are working on large amounts of data that is unlabeled and you want to have meaning, or you want to perhaps have some visualization or reduce the data or something to associate something. So these are the algorithms that you can use. So already as you venture into your machine learning journey, you have to know which tools to use for which task. So for example, I think it will be not ideal to use SVM on clustering tasks. So each method has its own best application. So you have to bear that in mind. And for a lot of time, you'll be required to reduce your data, like dimensionality reduction. One of the most used algorithm is PCA, Principal Component Analysis. Not only in machine learning, I'm actually using also PCA for me, for my robotics. It's a very handy tool, but it's very much used in dimensionality reduction of data. So for transfer learning, like I said, sometimes when you do not have enough resources, bear in mind some models such as if you are using convolutional neural networks or multi-layer perceptrons, you find that you have a data set which maybe if it's image classification, the data set is so big and you don't have enough resources to train. So what you can do is just pick the pre-trained model, and then these models are very much available. So you can use them in your problem, and then all you have to do is just retrain them on top, and they'll be able to give you the feedback or the result that you are looking for. So for classification, if you go on Google, there's ResNet, MobileNet, all these YOLO V4, VGG16, VGG19. These are deep learning architectures. Okay, so depending on what you would like to use. If, for example, if I want to use, if my application is a mobile app, which maybe is recognizing cats or dogs, I wouldn't get a model that is very heavy. I would get something that is very light, such as MobileNet, or maybe YOLO V4. VGG16 will be perhaps too, I don't know, depending on the phone. I think it will be too heavy for computing. So this is what you have to bear in mind. And for people that are interested in let's say, language modeling, maybe you don't really have to start from scratch. There's already some open, like there are already models that have been developed, such as BERT by Google, and OpenAI is supposed to be GTP3, not GPT-3. Excuse me on that one. Yes. So, then if, for example, if I want to develop, let's say, a model, what do I have to do? Either, like I've already mentioned, machine learning feeds on data, and the quality of data that you feed a machine learning actually influences the output that you expect. So the first thing that you have to do is you need to have a source of data when you want to use machine learning. You need to define the problem, and then you select this data. You have to bear in mind that this data comes in a way that is not ideal perhaps for a machine learning model. So most of the time, like Doc mentioned, most of the time you spend it on cleaning data so that it's actually formatted in such a way that the machine learning model that you are going to develop is going to understand, and the likelihood of producing the desired outcome is high. So you have your raw data, and you are going to have some data processing tools, of which I will show in the later slide, which tools that you can use, so that you structure your data depending on the data. If it's text data, what you have to do, if you, for example, if it's images, if you do not have enough images, you can do pre-processing, data augmentation, and so on and so forth. You can, and for example, if you have time series data such as sound, sometimes you find that you'll be required to convert that into the frequency domain to extract certain features that may be relevant. So after you've collected and you've processed your data, now you have your and this structured data is what you feed now into your learning algorithm. Already, since this is applied machine learning, it is up to you now to choose which machine learning you are going, a model algorithm you are going to use. Are you going to use one algorithm, a single algorithm, or you are, if for example, the problem is not, perhaps you don't expect one algorithm to be enough, can you actually combine two algorithms, which we call ensembles, to get a better result? So you have to choose from, for example, those algorithms I gave, and then once you train the models, maybe you can have, let's say, 5, and then you can do validation. From there, you choose the best model. And if you are satisfied enough, you can deploy your model and into maybe your web application or something. So basically, this is the workflow of machine learning, a typical machine learning example. So for machine learning, I'm going to be biased on this one. Most of the time, I'm a MATLAB fan, but I've come to appreciate that MATLAB, quite all right, it's very good, but not as open source as Python. So for machine learning, I would recommend Python. And these are some of the tools that will be required. Some of these APIs, such as TensorFlow, Keras, PyTorch, these are very, very rich, and they are very much used, especially, I think, even for industry and also for research purposes. And you also have let's say tools, libraries that you use specifically, some for data processing, some for visualization. For example, if you have CSV files, you find that pandas, you have to work with pandas a lot. And if you want to display results, you have matplotlib. And if, let's say, you can work actually in Jupyter, you can start with using Jupyter notebooks a lot. It's very interactive. So these are some of the libraries. They are not all the libraries, but these are some of the libraries that you are likely to use at one point in time as you do machine learning problems. And already, if someone asked, like, how do I, for example, do I have to go, let's say, to school to maybe to get the feel of machine learning? The answer is no. Machine learning is everywhere. Now we have a lot of GIT repositories at GitHub. There's so much support from the international community. And we also have our very own Zindi in Africa. This is a very good platform. And we have Kaggle. It's a world-renowned platform for AI. There's a lot of even competitions. If you want to participate in challenges, you can go to Kaggle and Zindi, but I would recommend Zindi because the problems that Zindi tries to bring out are actually African based, so we have to promote that. So these are international communities that I would recommend you guys to join, and you find that you get a lot of help. The question may be asked like, what skills do I need to have to really appreciate machine learning? So quite all right, machine learning, you can start from scratch, but for you to really understand and appreciate machine learning, I think you need some mathematics, not all mathematics, but basically linear algebra, matrices, some differential calculus, statistics and probability, and probably some information theory. And then you need some programming basics. And I'm again recommending Python because it's so open source and it's very easy to do. And not really a must, but a domain-specific expertise is actually an added advantage, especially if you are dealing with classical machine learning problems that may require feature engineering, manual feature engineering by yourself. This is a very good added advantage, because even medical diagnosis, let's say using X-ray, you find that a doctor, a radiologist is actually able to say, okay, they are able to spot a lesion just in the from the image. So already that's an added advantage. And the most important thing, of course, is interest. If you have interest in machine learning and not giving up, these are the skills that should definitely take you anywhere in your machine learning journey. The common challenges that you are likely to meet, perhaps in, and I mean in applied machine learning, one of the challenges is problem identification. So you really have to redefine your problem. What is it that you are trying to solve? And the problem that you are trying to solve, what is the goal? The goal, of course, is to create a better model, but the ultimate goal has to be perhaps for what's the benefit for the industry. And the other problem, which I think even Dr. Piri touched on, is data collection. It's different from it's different from, let's say, machine learning that is just pure research. If data that is used for machine learning pure research can just be used actually to verify if the model works fine or if the method works fine. But in applied machine learning, this becomes problematic because the data that you collect is ultimately going to affect your model, and you expect this product to actually be used somewhere by someone. If in the healthcare sector, for example, if the software maybe it's not correctly doing a diagnosis, it is very, very problematic. And then the other problem is maintaining models. This is difficult because we live in a dynamic world, and every time the data keeps changing. So models have to be maintained. They have to be updated according to how the dynamics are changing. So this becomes problematic. And then the other issue is assembling the right team. Applied machine learning is not just about a team of data scientists or AI engineers, but I believe it's more than that. Okay, it also has to bring on board people from other domains. And I myself, I would attest that it is difficult for engineers actually to come up with a solution that they are satisfied with. We always find a problem. But if you have someone, let's say from the let's say from the economics perspective of business, they are able actually to guide you. And then, of course, the other issue is security in terms of data security. If you are collecting data, how secure is it? And one last important thing is also ethics. You have to consider the ethics as you design your machine learning model, as you collect the data. And one of the challenges that happens is biases in algorithms. We have seen sometimes misclassification. For example, a justice system, which was rating the likelihood of someone committing a crime. You find that based on color, the blacks were classified as high risk and compared to whites. So that is problematic. And also ethics in the application, ethics also in the data and how you collect all these have to be considered. This becomes a challenge. And so if you are designing a machine learning model for use in business, please, you have to be mindful of this. So I'll just briefly talk about now the impact of learning in healthcare. So like I said, machine learning is not only in healthcare, but in so many fields. But I'll just focus on healthcare because this is the area where I'm very much based. And quite all right, in machine learning right now is being used in diagnosis of various diseases and treatment, early detection, training of staff. It's used in decision support systems for administrative purposes, and it's also used for welfare and also in drug research. So all these fields are actually leveraging the power of machine learning to enhance maybe how the service is delivered. So in healthcare, like for diagnosis, one of the thriving fields is in medical imaging in the radiology department and also in cardiology. So in cardiology, we have already systems that are able to detect if the heart is not functioning properly, and in time they're able to perhaps give a warning, a timely warning before maybe a stroke happens. So this is where machine learning is actually being applied to. And also in disease management for patients. In drug research discovery, we know to produce a drug is a long process. So sometimes, and they find that the organic compound formulas are so complex. So with the use of generative adversarial neural networks, we find that they are able to simulate certain chemical formulas, and given a disease, for example, maybe a malaria parasite, they are able, let's say, what drug formula can be perhaps be used, be produced. So this is why we are also using machine learning. And also we are using AI for simulations. And this is simulations, or let's say, of medical diagnosis and also robotics. Augmented reality, virtual reality, all these are very much used, and computer vision. So I already mentioned about early detection. Many conditions such as sepsis, seizure, also cancer, and also stroke. All these are some of the examples where machine learning or deep learning or general AI is actually being used effectively to do an early detection of these abnormalities. Then right now for welfare, we have smartwatches and fitness bands. One example I would give is Series 5 watch, Apple Watch. It has the capability of tracking your ECGs and also other vital signs that in case there's a problem, it is able to predict and give you a warning. So these are already, this is powered by machine learning. One example that I would give, for example, if I was to perhaps design a device for automatically doing a diagnosis of abnormal heart sounds. A stethoscope has been used, let's say, for so long in the medical field to do a diagnosis of various diseases, cardio-related diseases. So what we can do perhaps, for example, if this was a project, how can we use machine learning? How can we apply machine learning, for example, to create such a system? Because sometimes you find that the diagnosis of a patient may depend, maybe subjective sometimes. The doctor may be tired, or maybe the sense of hearing is actually deteriorating with time. So we can actually perhaps design a machine learning approach to help maybe doctors to do a job better, to help them. So this is an example I've given. This is, you have a patient and we get, let's say, a digital stethoscope, and we feed the signals that are the audio data into our microcontroller, and from the microcontroller through maybe wireless transmission we send to a smartphone, and then maybe in the smartphone or in the computer we have already trained a machine learning model. We have deployed it. We assumed we trained it quite all right, and it gives us the results. And these results, either if I'm a patient, I can review if I'm satisfied with the results, or if the results are suspicious, we can send now this information, let's say, to a doctor that is far. We can send the audio file to confirm what the machine learning had inferred from the patient data that was coming from. So this is just a problem, how it would go. So as from the machine learning perspective, this is what is done. How we would actually train a model. First of all, in the training stage, we need to collect some data. Now we have a lot of biosignal database, for example, for heart sounds for various conditions. So to train the model, we have to get data from, let's say, PhysioNet, and that data we split it into sets. Like I said, the training set, these are the examples, they are labeled. These are the examples that we are going to feed in the model so that it learns. And also we are going to use the test set perhaps to validate it. And then this data from the data from PhysioNet, for example, it's just the recordings of the heartbeats. And these recordings are very noisy. So what you have to do, this is why I said some domain-specific knowledge is important. What you have to do, you do a signal processing, such as filtration, and sometimes it's not enough just to have the signal in time. So what you have to do is you perhaps use another domain. So you transform it, maybe using Fourier transform, you transform it into the frequency domain, and then you extract the features. So after you extract the features, now you go to the training phase. You choose the machine learning model that you are going to use. And this example, I'm using a classification approach. So the machine learning model, you design your architecture of your machine learning model. If it is a convolutional neural network, let's say that you are using, convolutional neural networks are used maybe for images. So your image data, the sound data has to be converted in form of, let's say, images and spectrograms. And then you feed this image data into your model. You do the training and the validation, and then you export the best model. Then what you have to do is now perhaps you've already have a digital stethoscope somewhere. Now you can test this test of your model actually on this patient data that is coming. Of course, with the consent of a patient, because this becomes problematic. So then when you test, if the classifier, if it's able to classify, for example, if it's able to detect that, okay, the auscultations are not okay, and indeed the doctor verifies, and maybe 2 or 3 doctors verify, then you know that this is working okay. So this is one way we can actually leverage machine learning. When it comes to Zambia, like I said, it's not only in the healthcare sector where we can use machine learning. So this is now a question just not to me, but to everyone, not only to Zambia, but also Africa at large. How can we leverage machine learning, especially in the agro sector? Already it was talked about. In finance, in health, I've already given a glimpse of what machine learning can do in health, and also in legal affairs, education, media and transportation, and just for general purpose use. And you have to bear in mind, take into consideration what challenges you are likely to have. Earlier, Doctor mentioned about it's not always that you have to run to Cargo to collect your data sets. Some problems you have to create data sets for yourself. And this is why we need, I think, as Africa to grow, because most of the time we just run to already established data sets. And also ask yourself perhaps what machine learning what machine learning approach can I use, and what are the ethical implications? These are the questions that we have to ask ourselves, especially if we would like to appreciate what machine learning can do. In conclusion, AI or machine learning is reshaping our modern world by doing what we humans do, but more efficiently and more quickly and at a lower cost. And I'll stress this one most important thing. The purpose of machine learning or AI is to complement, not to replace human effort. And like where there's a notion that it's going to take people's jobs. Yes, some jobs are going to be replaced, but other new jobs are going to be created. And that is the way every industrial revolution works. And then the last point is that AI must be used within the prescribed frameworks of ethics, standards, and regulations in order to guarantee safety, security, and also unbiased use of algorithms. So with that being said, thank you very much for your attention. Spasiba za ulimani. Arigato gozaimashita.
Oh, Mr. Francis, your Japanese sounds like Bemba.
But well, I think some words in Japanese almost usually sound a bit like Bemba. So I guess it's well. Thank you very much, Francis, for that wonderful build up into how we can actually build our machine learning skills and getting to help us understand AI, we look at AI, machine learning and deep learning, and how what core skills we need to actually first build upon in order to harness these skills. And of course, you've also mentioned to say, of course, there are people, of course, that don't need, maybe that might fear math, but you also went on to share the various tools that are there that would then make it quite comfortable for certain people's preferences to learn and apply machine learning. So thank you very much for the wonderful session that you've given us.